Bismillahirrahmanirrahim. Assalamu alaikum. So let's start chapter 9 of D1. This chapter is regarding ratio, rate, time and speed. Initially we'll talk about ratio. So what is a ratio? Mathematically, ratio is a very useful tool to compare two or more numbers, or we can compare two or more quantities. But when we say quantities, the quantities have to be of the same type. The unit of measurement of the quantities have to be also of the same type. Now, when I am saying that the quantities have to be same and the unit of measurement have to be same, what do I mean by that? For that, when we take examples, the things will be clear. Okay, so let's start the chapter ratio, and let's begin with a simple example. Suppose there are 10 students in a class. So it could be any class of any grade, and there are 10 students in that class. Okay, among these 10, there are 6 boys and there are 4 girls. Okay, so we have a class, and the class in that class we have 10 students, and among these 10 students there are 6 boys and 5 girls. Now if I say that I am going to compare the number of boys with the number of girls, so I am comparing the same quantity. The quantity here is students. Okay, don't mix up with I'm comparing boys with the girls, but I'm comparing one group of student with another group of student. Okay, one group of student is boys, another group of students is girls. So I'm comparing how many boys are there in comparison to how number of the girls. Okay, so this ratio can be of two types: part to part. By part to part, I mean ratio of boys to girls, and that is equals 6. And when we are comparing one quantity with another quantity, we use a colon sign and we say 6 is to 4. So this is the comparison. Ratio of boys to girls. 6 is to 4. Okay? Now 6 is representing boys, 4 is representing girls. Since we are talking about ratio, so we'll further simplify it, and the simplification will be 3 is to 2. Okay? Whenever we are comparing ratios, the good thing is to simplify it to our lowest level. When we say that simplify it to the lowest level, 6 is to 4, in these two numbers there were some common factor. Some common factor was there, like the 2 was the common factor between both the numbers, between 6 and 4. So when we divide both the numbers with 2, so we have here 3 is to 2. Now these two numbers don't have any further common factor. The only common factor between these two numbers is 1. So this is the simplest form. So whenever we are representing quantities in ratio, the number has to be in the simplest form. By simplest form we mean the lowest integers. So now we have the ratio of boys to girls. 3 boys to 2 girls. So we are comparing group of boys with a group of girls, group of boys students with a group of girl students, and we got the ratio. There are 3 boys to 2 girls. Or in other words, the ratio can be the ratio of girls to boys. So now it will be other way, 4 is to 6, and when we simplify it will be 2 is to 3. Okay? So this was part to part. So among these 10 students, we took one part and compared it with another part. So ratio can be of, the second form of the ratio can be like comparing a part with a whole. So let's do that. So comparing now part to whole. So what it's going to be like number ratio of boys to total students, and that is 6 is to 10. So, but these are not in the simplest form. A common factor is there. So, let's simplify it, and it is 3 is to 5. Now, there is no common factor in it. So, the common factor only present is 1. So, it is in the simplest form. So, 3 boys to total number of, when the total number of 5, there are 3 boys. Okay? Simplest form. Or the ratio of girls to total students is 4 is to 10. That is 2 is to 5. So if the total number of students is 5, among these 5, 2 are girls and 3 are boys. Got it? The total is 5, and among these 5, 2 is girl, 3 is boy. So now we are getting an idea, a ratio, a comparison, how to compare one group with another, one quantity with another. So as you can see that even in some recipes, when you are cooking, there is certain quantity that you say, okay, you have, if you are baking a cake, that you are going to take 3 eggs with 1 cup of flour, right? So these are kind of the ratios. These are the combinations which are very useful in understanding certain things. Okay? So now let's take an example from a book. So I'm going to take practice now 2. Which is on page 205, and in this we are going to compare A part, 240 grams, a ratio of 240 grams with 1.8 kg. We are comparing 2 quantities. Now, when we are comparing 2 quantities, the definition says the quantities have to be of same type, and the quantities have to be the measurement of the unit of measurement of quantities has to be same as well. Okay. Now in this ratio, one quantity is in grams and another quantity is in kilograms. So the unit of measurement is not same. So our comparison is not correct. So first thing is we have to make sure that the unit of measurement of both the quantities is same. Now either we can have both the quantities in kilograms or we can have both the quantities in grams. But making this quantity into grams will remove the decimal, and we always feel comfortable when the decimal is not there. So convert these kilograms to grams. So what do we have to do that? How we are going to do that? 1 kg is equal to 1000 grams. Okay? So it means that if it is 1.8 kg, what are we going to do? We are going to multiply it with 1000. So the comparison will be now 240 gram is to 1800 grams. Now both the quantities are in grams. So now this is a proper way of to compare two quantities, same units. So it's a ratio. The ratio has to be in the simplest form. The integers have to be in the simplest form. There shouldn't be any common factor. So, but here we see that the common factors are there. Now, how to simplify? You can simplify whatever way you like, but if you are not getting any clue that how to simplify it, okay, first thing is that we can divide it by 10. So what do we have here? 240 reduced to 24 grams is to 180 grams. But still, okay, it is simplified, but still common factor are there. Now, 12 twos are 24. So 2 gram is 2, and 12 15s are, if we multiply 15 with 12, what do we get? 180. So 15 grams. Now this is the simplest form. Okay. The ratio of the two quantities whose measurement was given in grams now is in the simplest form. Okay. Let's take another example. Now, suppose we have fraction if we have a ratio in this form that we are comparing one fraction with another fraction. Now, we are always not comfortable with fraction, not comfortable with decimal. So, the whole number is something which we make us comfortable. So, to remove these fractions, to remove these denominators, what do we have to do? We can have the LCM of both the denominators and multiply both the sides. You see, when we are comparing two quantities in a ratio, we can divide both the quantities with the same number, or we can multiply both the quantities with the same number, right? Now what I am going to do is the LCM of 5 and 9, let's take the LCM. So it is 5 ones 9, so it is 45, okay? So I am going to multiply both the quantities, both the fractions with 45. 45 into 3 by 5 is to 8 by 9 into 45. Okay, 5 ones are, 5 nines are, 9 ones are, 9 fives are. Now what do I have here? 27 is to 40. Now do I have anything common factor in both these numbers? No, I don't. 27 is an odd and this is even. It's not divisible by 2, it's not divisible by 3. Okay, so this is the simplest form of the ratio, and the common factor in these two numbers is 1. So we have simplified the fraction by multiplying both the side with 45, and the ratio we have is in the simplest form. Okay. hope you got the idea that what do we mean by ratios. We are comparing two quantities, and the quantities have to be of the same type. The quantity unit of measurement of the quantities have to be the same. There can be a fraction. Whenever there is a fraction, we can solve the fraction by multiplying both the quantities with the same number, or if we are dividing, we are going to divide both the quantities with the same number. Okay, so now let's take another example. I'm going to take practice now 3 now. And this is on page 208. Okay, now we have here (3a is to 7) equals 8 is to 5. Now we have a ratio on the left hand side and we have ratio on the right hand side. Okay, and both the ratios are equal. Now in this case we have to find now what do we have to do? Now before we solve this, whenever we have some ratio like 8 is to 5, we can also write the ratio as, this is can also be written as 8 divided by 5. Okay, this same ratio, we are comparing one quantity, one number with another number. This ratio can also be written in this form, 8 divided by 5. Okay, the first number becomes numerator, the second number becomes the denominator. Okay, and if we have this situation that we are in an equation and we have two ratios and we have to find a value of an unknown, so what are we going to do? I am going to divide 3a by 7 equals 8 divided by 5. Okay, now this thing is converted to this. When we have this form, it is very simple, and we know that we can cross multiply this and it will be very easy to find the value of the unknown. So we are going to do the same. So 15a is equal to 8 into 7, which is 56. You can write it 56 or we can write it like this. So a is equal to 56 over 15. So this is the value of a, or we can write it like this, 3 whole 11 over 15 in the mixed fraction form. Okay, mixed form. So this was the way to find the value of an unknown, and when we are in this situation, we can write the ratio as fraction, and when we write the ratios as fraction, it becomes easy by cross multiplying that we can find the value of the unknown as well. Okay. So let's do some question from the exercise as well now. So let's take some questions from exercise 9a. Exercise 9a, question 1. Now C part. So we are going to compare 0.45 is to 0.85. Okay. So in this ratio we have two decimal numbers less than 1. So to remove this decimal thing, what are we going to do? If we multiply, as I said that in the ratio, if we have to multiply, we have to multiply both the sides, both the quantities, both the number with the same number or same quantity. If I multiply both the sides with 100, what do I get here? 45 is to 85. Now the numbers are the whole numbers, integers, and it is simple to deal with them. Okay, now these two numbers are ending with 5, so obviously they have some common factor. So let's divide it by 5. So 5 9s are 45 and 5 1s are 5 and 17. So 9 is to 17 is the simplest form. So first thing what we did when we have the decimal numbers, we multiplied with some number, some whole number. We multiply both the sides with 100. So the decimal was removed. We have the whole numbers here. Now to get the simplest form, 5 was the common factor. So dividing both the sides with 5, now we have the simplest form of the ratio. Okay. Up to now we are talking about how to deal with ratio and how to simplify it. Okay. So let's take another part from the same question. Part D. So I have here 580 ml is to 1.12 liters and 104 ml. So as I have said in the definition of the ratio, this is a tool to compare two or more quantities. So here we are comparing three quantities and we have to simplify it, but this ratio cannot be simplified because this is liters and these two are milliliters. Okay, so the measurement tool, measurement unit has to be same. So 1 liter is equal to 1000 ml. Okay, so we are going to convert these liters to ml. So we will multiply this with 1000. So 580 ml is to 1120 ml is to 104 ml. Okay. Now all the quantities, all the numbers have the same unit, milliliters. Now we have to simplify it. So by simplifying, you can simplify in steps. If you cannot simplify directly, you can simplify in steps. So what I'm going to do, I'm going to divide all with 2. So here I have 290 ml is to 560 ml is to 52 ml. Okay. Still ending with 0, ending with 0, ending with 2. Still I can further simplify. I'm going to further divide by 2. So what I get here, 145 ml and is to 280 ml is to 26 ml. Okay, now since this is odd, these two are even, now there is no more common factor between these numbers. So this is the simplest form of these ratios. Okay. First we changed the unit of measurement, multiplied with 1000. Then we simplified by dividing by 2. You can, if you can simplify it directly, you can divide it by 4, and because it was ending with 4, you could have done that. But if nothing is coming to mind, you can simplify in step by step so that you are sure that whatever you are doing, you know, and it's easy for you. Okay. Now let's take one more part from the same question. And I'm going to do part E, which is 2 over 3 is to 3 over 2 is to 5 over 8. Okay, now we have to simplify these ratios. Okay, 3 fractions are compared. How to do that? Let's take LCM. 3, 2, 8, 2, 3, 1, 4, 2, 3, 1, 2. Okay, now the LCM is 6, 12, 24. So I'm going to multiply all the fractions with 24. So 24 into 2 over 3 is to 24 into 3 over 2 is to 24 into 5 over 8. So what do I have here? 8, 3, 8's are 24. So 8 2's are 16 is to 12. 3 12's are 36. 8 3's are 24. 3 5's are 15. Okay? And two numbers are even, one is odd, so cannot be simplified further. No more common. So it even we cannot divide it with 3. So it is the simplest form of these ratio. Okay? Fraction is removed by multiplying a common number for all the fractions, and the simplified form is here. Okay, I hope that you got some idea about the basic of the ratios, what are the ratios and how to simplify the ratios. Okay, so next time we'll solve some more questions regarding the ratios, and we'll see how the ratios are being used. For now, thank you very much.